This Science Physics Paper 1 and 2, 2009 May. I'm going to go through the MCQ section. Okay, in this MCQ, in question number 1, it shows a 40 vernier calipers that was used to measure the diameter of a coin. Given that its error is positive 0.3 mm with its jaws fully closed, what is the actual diameter of the coin? Okay, over here you have got to take note of two things. The first thing, of course, is the error. Okay, it's a positive 0.3 mm, and later we'll see okay how we can actually adjust the error. Next thing, okay, we have to look at these vernier calipers. This vernier caliper is a bit different because the scale here reads 0.1 mm. Okay, but the one in your textbook I think reads cm. Okay, but it doesn't matter. Okay, so over here just take note that it is 0.1 mm. So how do we read the vernier calipers? First thing, we have to look out for the 0 at the vernier scale. Okay, so the 0, where is it pointing to? This line directly above the 0 is pointing to the reading 7. Okay, how do we know it's 7? So let's count it. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so over here this line is pointing somewhere here. So it's actually 7 point something mm. Okay, so what's the something mm? So we have to look okay at where the two scales coincide. So let's check it out. Okay, where does the two lines coincide? So we know that the lines actually coincide at 8. Okay, look over here. Okay, the two lines actually coincide here. So what we have to do, okay, of course, is to just add on with 0.8 mm because the accuracy is up to 0.1 mm. So over here we have to add 0.8. So we have 7.8 mm. Okay, but do not stop here. This is not the final answer because there's an error of plus 0.3 mm. So the question now is, do we add to this error or do we minus it off? Okay, the answer is we will minus 0.3 mm. Okay, the answer should be 7.5 mm. Okay, why are we subtracting 0.3 okay, from the reading? Okay, because over here, okay, even though over here it says that it's a positive 0.3 mm error, okay, just imagine this. Okay, on a one fine morning, okay, you might want to weigh your own weight, and you find that okay, before you weigh your own weight, okay, the reading on the scale is already plus 3 kg. So after weighing, you actually have to minus off 3 kg from your reading, okay, to get the correct weight. Okay, so let's say okay the weighing scale is 47, so we have to take 47 minus 3. Okay, your actual weight is 44 kg. The same thing over here. Before you measure the coin, the vernier calipers already read plus 0.3 mm. So the final reading you have to minus off 0.3 mm to get 7.5 mm. So the answer is 7.5 mm. Okay, now let's move on to question number 2. The diagram below shows the scale of a micrometer screw gauge used to measure 400 pages of book. So be very careful. Okay, I suggest that you actually highlight the keywords 400 pages, and this is a micrometer screw gauge. Okay, so what is the thickness of one piece? Take note, okay, we are trying to find one piece and not 400 pages. Okay, so we're going to find one piece of paper. Over here, how do we read it? Okay, first we read it. Okay, so first we read the scale over here. So just take note, okay, the scale is in mm. So it's 0, 1, 2, 3, 4, 4.5, 5, 5.5, and we know that it's 5.5 something mm. Okay, so we have to add the reading, okay, that's on the ring. Okay, so the reading here reads 30, 31, 32, 33, 34, 35. Okay, so it coincides at the line 31. So we have to add 0.31 mm. Okay, so the answer is 5.81. Okay, but please, okay, guys, do not stop there. You actually have to divide this answer by 400. Okay, and the answer that you will get is actually B, 0.029 mm. Now for question 3, the diagram below shows a simple pendulum at the ends and center of its swing. The period of this pendulum is 1.2 seconds. Okay, so again, I suggest that you underline the key points. The period okay, is 1.2 seconds. Which label arrow shows the distance moved by the pendulum in 0.9 seconds? Okay, so 0.9 seconds is less than 1.2 seconds, and this is less than a period. Okay, so we got to look out for um, the swing that okay represents 0.9. Okay, so this one okay represents half a period. Okay, because over here it just swings okay for one time. Full period is supposed to be like that. So this is half a period, and this is one period. Okay, so the only answer possible is over here. Okay, swings for a quarter period, and then it swings for half a period. So add up together, it swings for 3/4 period, and 3/4 times 1.2 is actually 0.9 seconds. For question 4, two forces x and y act on an object, causing a resultant force z, which diagram best represents the directions of vectors x and y and their resultant z. Okay, so over here, please underline the keywords. Okay, so we are trying to find the resultant z from x and y. Okay, so let's go through the options. For option number A, okay, so x and y and the z is over here. Okay, so this is not possible because z will be somewhere around here. Okay, if you have constructed the triangle, and over here, okay, x and y, okay, z is not possible to be here. Okay, it should be somewhere here. Okay, while over here x and y, z is not supposed to be here, it should be somewhere here. Okay, so the solution is D, because x and y will produce a vector in between, okay, x and y, and this is z. Okay, so by triangular methods, okay, I can actually shift y to this part. Okay, so y can be this one. Okay, from bottom to head, bottom to head. Okay, and I simply join them up, and this is z. Okay, so the answer is D. Okay, so just imagine that this object, one is pushing in this direction, the other one is pushing this direction, the resultant direction will be over here. Okay, so you have to make use of some common sense too. And for question number 5, I'm not going to go through it, okay, because this is easy enough. For question 6, okay, I'm not going to go through it. And for question number 7, okay, a cube of ice is placed on a metal table. After some time, the ice starts to melt. Which of the following is incorrect? Okay, so please take note which of the following is incorrect about the transfer of energy between the ice cube and its surrounding. Okay, so the option is A. Convection currents occurs above the ice cube, causing it to melt. Okay, so this is the ice cube, and this statement is incorrect. Okay, convection current above causing it to melt. Is it possible? No. Okay, because over here, okay, look carefully. The surface above the ice cube, this part, okay, is cold, and cold air actually sink. Okay, this won't set up a convection current. Okay, so because the cold air remains here. Okay, while B, C, and D, all these statements are actually correct. Okay, heat is conducted from the table onto the ice. Okay, that's correct. Heat from the surrounding is absorbed by the ice through radiation. That's correct. Heat is conducted from the surrounding air into the ice. Okay, this is correct also. Okay, now let's move on to question number 8. Question number 8. An experiment is carried out as shown in the diagram below. Okay, why does it take a long time for ice to melt even though water